Hello students, welcome back to online lecture of M.G. Shah Vidya Mandir and Junior College, Bahubali. Welcome to 12th Maths first topic 2nd matrices. Subunit-Inverse by Adjoint method. Hello students, in 12th Maths first we had started topic number 2nd matrices. Student, yesterday in last video we had seen one of the method of finding inverse of the given matrix, given square matrix, that is adjoint method. We had not seen what is the adjoint method, but we had seen some basic concepts which are useful for finding inverse by adjoint method, that is minor of a element and then cofactor of the given matrix. Are you remember both the things? We find minor of the element by dividing that rows or columns and we take the remaining determinant. And cofactor, we use the formula for cofactor, finding the element minus 1 raised to I plus j into minor of that matrix. Okay, we had seen some example which are based on these minor of matrix and cofactor of a matrix. Now these two things are useful in finding inverse of a square matrix by adjoint method. Today we will see adjoint method of finding inverse of a given matrix. So let's start. Before starting examples on this adjoint method, we will see what is the definition of adjoint. See what is the definition. Suppose the adjoint of a square matrix A is equal to Aij. A is equal to Aij. It is square matrix. Okay, it is a square matrix of order n by n. See, the adjoint of a square matrix A is equal to Aij of order n by n is defined as transpose of the matrix Aij. Okay, we define this as transpose of matrix Aij. या matrix चा काय लिहिणार आहे आपण? Transpose लिहिणार आहे. Okay, so what is the Aij? Aij are the cofactors. Okay. So see, suppose if the given matrix is A matrix मध्ये elements असतील A11, A12, A21 and A22. This is the matrix. So you first find cofactor of this matrix. Cofactor of this matrix we denote by A11, A12, A21 and A22. This is the cofactor, and we find adjoint by transpose. Adjoint of A is transpose of cofactor matrix. Transpose of cofactor matrix. So what is the transpose of cofactor matrix? We write this as A11, A21 and here A12 and A22. This is called the transpose of the cofactor matrix. While writing transpose, you write row by column. Row का लिखते अपन column लिखते. So for finding inverse by adjoint method, you first write the given matrix A. You find A matrix is, suppose this is 2 by 2. I have given example of 2 by 2. There may be 3 by 3 matrix. You first find cofactor of each element. How to find cofactor? You find first minor and then cofactor. Minor cofactor, minor cofactor. So प्रत्येक element चा cofactor काढून घ्यायचा. Then write cofactor matrix. Take transpose of that co-matrix as adjoint of A. Transpose म्हणजे काय नाव आहे? Adjoint of A. And then you find A inverse by using formula. A inverse is equal to 1 upon determinant A into adjoint of A. This is the formula for finding inverse by adjoint method. This is A inverse and here we find adjoint of A. So it is called the adjoint method. Okay. So for finding inverse by adjoint method, you first write the given matrix. First step you find determinant A. Second step you find minor. Third step you find cofactor. Fourth step you find cofactor of the given matrix and write transpose of this matrix as adjoint of A. In this way you can solve example based on this method. So we will see examples on it. See first example. If matrix A is given 2, -2, 4, 3. I read row wise. Then find A inverse by adjoint method. Students, see, this is A matrix. Order of this A matrix is 2 by 2 because there are 2 rows and 2 columns. You know all these. By using adjoint method means here we have to find the adjoint method. We find A inverse by formula adjoint of A upon determinant A. You remember the formula for finding inverse by adjoint method is adjoint of A is equal to 1 upon determinant A into A inverse is equal to 1 upon determinant into adjoint of A. We find A inverse by using adjoint method as 1 upon determinant A into adjoint of A. Okay. So here you can find determinant A easily. And how to find adjoint of A? We find adjoint of A by cofactor. Okay. Cofactor of that element is the adjoint of A. So first we find determinant A. Determinant A is equal to 2 -2, 4, 3. 3 2s are 6 minus 2 2, 4 2s are 8 minus 8 is equal to 6 plus 8. Therefore, we get determinant A as 40. We get value of determinant A as 40. Now you find cofactor of this matrix. For this, you find first minor of this given matrix. For given matrix A, for given matrix A, we find first minor of first element M11. M11. This is the minor of first element. Which is the minor of first element is 3. Then M12 is M12 element is -2. So minor of this matrix is 4. M21 is, you neglect this -2. And M22 is 2. Okay. We get first you find minor. Then you find A11. A11 is equal to, or you can write here. After the answers we will get A11 is equal to, A means cofactor. Okay. Cofactor is -1 raised to 1 plus 1 into M11. M11 means here 3. -1 raised to 2 means 1. 1 into 3 is 3. Okay. Then M12 is, you find M12, then M21 and M22. Okay. What is the M12? First A12 element is -2. So its minor is, you delete this notes, you get 4. Okay. So you find cofactor A12 is equal to -1 raised to 1 plus 2 into 4. That is -4. Okay. Here -1 raised to 3 means -1 into 4 is -4. M21, you neglect this row and column, you get -2. So A21 is -1 raised to 2 plus 1 into -2. That is this minus becomes plus. And lastly M22, minor of this element is 2. A22 is equal to -1 raised to 2 plus 2 into 2. -1 raised to 4 means plus, that is equal to 2. So you get cofactor cofactor of matrix A as adjoint of A. Cofactor of matrix means adjoint of A. Therefore, we get, you write adjoint of A is equal to cofactor matrix, that is 3 minus 4 2 2. We get this as adjoint of the given matrix. Okay, this is the cofactor. Okay, cofactor of A. Then adjoint of A is equal to 3 minus 4 2 2. This is the 3 minus 4 2 2. This is the adjoint of A. Okay. Now you find A inverse. Therefore, A inverse is equal to 1 upon determinant A into adjoint of A. 1 upon, what is the value of determinant A? 14. Into adjoint of A is 3 into minus 4 2. Okay, this is our final answer. In this way we find A inverse by adjoint method. This method is called as adjoint method. Okay. See students, second example. If A is given matrix, find A inverse by adjoint method. First example, the matrix A is of order 2 by 2. This is of the order 3 by 3. Okay. So first thing you write first the determinant A. Determinant A is equal to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. You find this determinant. How you find 2 2 to 4 minus 1. Here minus and this minus 1. 2 ones are you remember how to solve this determinant? 2 ones are 2 minus 2 minus minus 1 plus 1 into bracket 1 minus 2. So we get determinant as 2 into 3 minus minus plus 1 into minus minus plus 1 minus 2 plus 1 is 1 plus 2 into minus 1. 6 plus 1 minus 2. 6 plus 1 7 minus 2 is 5. So we get determinant A as 5. Okay. First we find determinant A as, see students, here minus minus plus and here minus sign is there. So it becomes minus 2 means 4. We get value of determinant as 4. Now you find cofactor of matrix. And how to find adjoint of A? We find adjoint of A by transpose of cofactor of A. So we first find cofactor. For this you find first element. What is the minor of this element? A11. You find minor of element A11 as C. Observe 2 to the 4. Okay. Or directly you find cofactor A. How to find cofactor? Minus 1 raised to 1 plus 1. I will directly find C. First you find minor M11. Minor of first is the, you delete this row, 2 to the 4 minus 1 1 is 1, that is equal to 3. Therefore A11 is equal to minus 1 raised to 1 plus 1 into M11 is 3. That is minus 1 raised to 2 is 2. So we get A11 as 3. Okay. Similarly, you find minor of second matrix. Second element M12. M12 means this element. You delete this first row and first column. Minus 1 into 2 minus 2 minus minus 1. So you get as minus minus plus 1 minus 2 plus 1 minus 1. Similarly, you find cofactor A12 is equal to minus 1 raised to 1 plus 2 into minus 1. Minus 1 raised to 3 means minus 1 into minus 1. this becomes plus 1. Okay. Similar third element, minor of A1 3. This element, you negate this row and column. 1 1s are 1 minus 2, that is equal to minus 1. A12 is equal to minus 1 raised to 1 plus, now this is the third element, okay, 1 plus 3 into minus 1. Minus 1 raised to 4 is positive. Even number असेल तर हा positive होणार आहे. So M13 is minus 1. Similarly, you find M32. Okay. Now M21. M21 means this element. Okay. How to find this element? See, you neglect this row and this column. So what remains? Minus 2. And here minus 1. Minus 1. Into, which is equal to minus plus 1 and minus 2, that is minus 1. And find cofactor. A21 is equal to minus 1 raised to 2 plus 1 into this minus 1. Minus 1 raised to 3. Okay, minus 1 raised to 3 means minus 1 and minus 1 means we get plus 1. M21. A21 we get as 1. Okay. Next, M22 means this element. You neglect this row and column. 2 2s are 4 and 1 1s are 1. 2 2s are 4 minus 1 is equal to 3. A22 is equal to minus 1 raised to 2 plus 2 into 3. Minus 1 raised to 4 positive plus this is means 3. We get A22 as 3. Next, M23. Second column, third element, third row. Okay, this element. You neglect this row and column. 2 1s are 2 minus 2. Middle set minus and minus 1. बघा हा रो आणि हा कॉलम निगेट करून राहिलाच घ्यायचा आहे. हे व्यवस्थित लिहिता आलं पाहिजे तुम्हाला. minus plus 1. Minus 2 plus 1 is minus 1. Therefore, A23 is equal to minus 1 raised to 2 plus 3 into minus 1. Minus 1 minus 1, that is plus 1. Okay. Next, M31. M31 means this. You neglect this row and column. 1 1s are 1 minus 2. 1 minus 2 is equal to minus 1. A31 is minus 1 raised to 3 plus 1 into minus 1. This is positive, means minus 1. Next, M32 means this element. Okay. You neglect this row and column. Minus 2 and minus 1. Minus 2 minus minus 1. Minus plus. Minus 2 plus 1 minus 1. A32 is equal to minus 1 raised to 3 plus 2 into minus 1. This is odd number, minus plus. So we get A31 as 1. Next, last one, M33. This element, you neglect this row and column. 2 2s are 4. Minus 1 is equal to 3. So we get A33 as minus 1 raised to 3 plus 3 into 3. This is positive, so answer is 3. Okay. Here we find this minor, and from this minor we find cofactor of each element. There are 9 elements because this is matrix of order 3 by 3. Now you find cofactor. Cofactor of matrix A is equal to, what is the cofactor? You write C 1 by 1 3, 1 minus 1, then 1 3 1, then minus 1 1 2. Okay, this is cofactor. And how to find adjoint of matrix A? Therefore, adjoint of A given matrix is, We find by transpose of this matrix. ट्रान्सपोज करताना काय करतोय आपण? रो कॉलमनं लिहितोय. हा रो इथं कॉलम लिहायचा. 3 1 -1 1 3 1 -1 1 3. Write in this way. Okay. So we get adjoint of A. So by using formula you find, therefore we get A inverse is equal to 1 upon determinant A into adjoint of A. So what is the determinant A? We have to find 1 upon 4 into what is the adjoint of A? Adjoint of A is 3 1 -1 1 3 1 -1 1 3. In this way we find A inverse as 1 upon 4 into matrix 3 1 -1 1 3 1 and -1 1 3. Okay, this is the method of solving inverse, finding inverse by adjoint method. You remember here, you first find minor, then find cofactor. Minor च्या पुढे जरी cofactor लिहा किंवा तुम्ही स्टेप खाली घेतलं तरी चालेल. एका एलिमेंटचं काढून झाल्यावर एक लाईन रिकामी सोडा, म्हणजे तुमचं गोंधळ होणार नाही. पहिल्याचा मायनर काढा, मग त्याचा कोफॅक्टर काढा, एक लाईन सोडा. पुन्हा नेक्स्ट एलिमेंटचा मायनर कोफॅक्टर, असे प्रत्येक एलिमेंटचं मायनर कोफॅक्टर काढून घ्या. देन राईट कोफॅक्टर मॅट्रिक्स आपण रो वाईज दिलाय तसं व्यवस्थित द्यायचा. A11 म्हणजे पहिला एलिमेंट, A12 म्हणजे इथला दुसरा, A13 म्हणजे इथला. तुम्ही हे असं इथला उभं चुकणार आहे. ओके, इन दिस वे यू राईट. देन हाऊ टू फाइंड adjoint of A? ह्या कोफॅक्टर मॅट्रिक्सचा ट्रान्सपोज घ्यायचा. ट्रान्सपोज म्हणजे काय? रो आहे तो कॉलम लिहिणार. And then by using formula we find A inverse. Okay, understand? I had given one example of 2/2 and another example of 3/3 matrix. See one more example. If A matrix is given 1 2 3 4, verify that A into adjoint of A is equal to adjoint of A into A is equal to determinant A into R. Okay, so here A matrix is given, we find adjoint of A and determinant A. First we find determinant A. Determinant A is equal to 1 2 3 4. 4 1s are 4, 3 2s are 6. Therefore we get determinant A as -2. Okay, now you find determinant A into I. Determinant A into I means, see here, what is the value of determinant? -2. And we take I as identity matrix. It is of order 2/2. So we take here identity matrix of order 2/2. That is -2 into 1 0 0 1, which is equal to -2 0 0 and -2. Okay, we call this equation number first. Now you find adjoint of A. For this you find cofactor and minor of that element. First you find here minor of element. What is here? M11. Now first you find M11. M11 is here 4. Then M12 is here. M12 is, see, this is the element 3. M21 is 2. And M22 is 1. Okay. From this we find cofactor. A11 is equal to -1 raised to 1 plus 1 into M11 is 4. -1 raised to 2 means here 4. Then you find A12, A21 and lastly A2. -1 raised to 1 plus 2 into 3. Means -3. Here -1 raised to 2 plus 1 into 2 minus 2, and lastly here -1 raised to 2 plus 2 into 1 means here 1. So we get here 4 -3 -2 and 1 as cofactor. Okay, therefore cofactor A is given by, what is the cofactor? See, 4, -3, -2 and 1. From this cofactor you find adjoint of A. Therefore, adjoint of A is equal to transpose of this matrix. So what is the transpose? 4, -3 and -2. Okay. Now you find A into adjoint of A. Now A into adjoint of A is equal to, what is the given matrix A? 1, 2, 3, 4. And what is the adjoint of A? We had calculated here 4, -2, -3, 1. Here you multiply. This is the matrix of order 2 by 2 and this is 2 by 2. So their product is of matrix order 2 by 2. See how you find 4 ones are 4. Then -2 threes are -6. Okay. You multiply first row to first column. Then first row to second column here. 2 ones are 2 and this is plus 2. 3 fours are 12 minus 3 fours are 12. 3 twos are 6 plus 4. Okay. So we get this matrix as, see, we get this matrix as -2, 0, 0, -2. You call this equation number 2nd. Next you find adjoint of A into A. Now again, adjoint of A into A is equal to, what is the adjoint of A? 4, -2, -3, 1 into, what is the given matrix A? 1, 2, 3, 4. You find this. See what happens here. 4 ones are 4, -3 twos are 6. 4 twos are 8, -4 twos are 8. 3 ones are 3 plus 3. 3 twos are 6 plus 4, which is equal to -2, 0, 0, -2. You call this equation number 3rd. Observe equation number first. -2, 0, 0, -2. -2, 0, 0, -2. -2, 0, 0, -2. From equation 1, 2 and 3 you can write as, from equation 1, 2 and 3 we write as, see what we write as, A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into, hence the proof. We want this to true, hence we had true. Okay student. So students, in this video we had seen what is the method of finding inverse of a square matrix by adjoint method. For this we find first minor of the matrix and then cofactor of the matrix. And what is the transpose of cofactor is adjoint of A. And then by using formula A inverse is equal to 1 upon determinant A into adjoint of A, we had find the inverse. So your today's homework is try to solve exercise 2nd in this topic in page number 52, 51 and 52. Exercise on textbook page number 51 and 52 in your notebook. Which are the questions here? Question 1 is of finding cofactor. Question 2 is also of finding cofactor is there. Question 3 is of finding adjoint of A. Means you have to find cofactor and take transpose of there. Question number 4 is like this. Question number 5 is finding inverse by adjoint method. So there are how many types of question in asked here? Find cofactor, find minor, find adjoint, okay, and then find inverse. 4 steps are there. Any type of question is asked for exam. Okay, understand? All these exercises solve yourself in your notebook. We will stop here. Here, first part of this topic is also completed. Finding inverse by elementary transformation and by adjoint method. Okay, thank you.